All right, so back here at the workshop, trying to figure out how to get this to autofocus on certain parts. So far, what I've done is created a digital way, wireless digital way of communicating with the Z gantry of the laser. So I can physically move the laser up and down manually from a distance. So how can I make this setup a little better? Well, what about autofocusing? And for autofocusing, the way I'm going to tackle this autofocus is using this laser distance measuring tool. And I bought this off Amazon for $15, and it has this triangulation type of laser distance measuring sensor in the front here. And I'm going to connect it to an ESP8266. We're using ESP now, so it could communicate with the ESP in here and the ESP on the gantry. When I first got this, there was a couple problems I didn't know how to solve, and with the help of ChatGPT and tools that I have, I was able to figure it out. This device right here, or this sensor, has 4 pins, 3.3 volts, ground, RX, and TX. Originally what I did was I unplugged it from the laser itself, connected it directly to the ESP8266, created some code just to see if it was reading distance. There was nothing coming out. Anywhere I placed it, as far as something in front of it, distance-wise, nothing was producing anything in the plotter or the serial readout. So, what did I have to do in order to figure out what this does and how does it communicate with the rest of the software and circuitry of this laser? I have this oscilloscope slash digital logic analyzer, and what I ended up doing was using the digital readout for logic analyzing, connected it to the TX, which is the transmitter pin and ground of the actual sensor, and ran a trigger value at a certain frequency because we believe that this was running at some broad rate of 9600. And I kept it connected to this, turned it on, tried to read some distances, and this formation of on and off at specific microseconds appeared. And you can't really do much just by looking at this, but luckily this software has some type of decoder for UART, because this is a UART control. So this is the UART response, and we found that using this UART response, we could actually communicate directly with the laser with knowing what the start and end commands are for this to function, without using the internal setup and circuitry that this came with. We could run this directly to the ESP8266. I'm not at that stage yet. What I am at the stage now is, because there was some scaling factors that were a little off with this, is that now I could turn on the laser, and I can transmit the data not only to the original setup here, but to the ESP8266, and I get the same readout. So we broke ground today, being able to do this, from using a logic analyzer to figure out the UART code to actually, with ChatGPT's help, create code that I could put onto the 8266 to actually get some distance readout. So let's show this in function. I'm going to turn it on, and I'm going to hold it down till we see some readout. I'm going to put my hand right here. We get a readout of 0.198 meters. Down here, we have a readout of 0.076 meters. And the reason why there's a difference here is because you can see on the laser head, the program is set to have the distance read from the back end of the laser and not from the top of the sensor. So if I change that here, I think I have to do that, hit readout, put my hand in front, we get a readout of 0.075, we get a readout of 0.075 essentially. Just moved my hand a little bit so it wasn't perfect. So we have direct communication with the ESP8266, which is great. Using this code and figuring out how to actually communicate with this, now I could actually create a code where this will now communicate with everything that I already have to actually move the head automatically using the distance location sensor. So stay tuned for that part.